Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam exam and other exams related to physical science. And my courses are absolutely free of charges. And also guys, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my live classes absolutely free of charges and are going to help you to crack the exams related to physical science. Okay, and this is the fifth part of PYQ series of June 2019. Okay, so I'm going to start. I'm going to start with the question which was left last time because of technical error. Class was ended, right? So I'm going to start with that question. Okay, so let's start now. Let me just check voice as well. Okay, am I audible or not? Left last time. Yeah, I'm audible. Okay, so I'll start with that question which was left last time, means in last lecture. So this is the fifth part of the CSIR Net Physics PYQ June 2019. Okay. Okay. The question is the permittivity the permittivity of the permittivity tensor of uniaxial uniaxial and isotropic medium and isotropic medium in the in the standard Cartesian basis is 4 epsilon 0 0 0 is in the okay permittivity tensor is given 4 epsilon 0 0 0 and then 0 4 epsilon 0 0 and then 0 0 9 epsilon 0. Okay, 9 epsilon 0 where epsilon 0 is a constant the wave number of an electromagnetic plane wave of an electromagnetic plane wave polarized along x direction, polarized along x direction and and propagating propagating along the y direction, along the y direction in this media in terms of in terms of in terms of the wave number, in terms of the wave number k naught of the wave of the wave in vacuum is. Okay, options are option number A is 4k naught, 4k naught. Option B is 2k naught, 2k naught. Option C is 9k0, 9k0, and option D is 3k naught. Okay, 3k naught. Very simple question. Question is the permittivity tensor of a uniaxial and isotropic medium in standard Cartesian basis is given. Okay, this is the permittivity tensor given, where epsilon 0 is a constant. The wave number of electromagnetic plane wave polarized along x direction and propagating along y direction in this media. So you need to find out the wave number for electromagnetic plane wave. Okay, uh, which is polarized along x-axis and propagating along y direction in this medium. Okay, and in terms of the wave number of the wave in vacuum. Okay, in terms of k naught. Okay, you need to find out the wave number in vacuum. Okay, wave number of the wave in vacuum. Very good question and very simple. Okay, one line solution question. Okay, so we know k naught, that is wave number in wave number of the wave in vacuum. We know that is k equal to omega upon c, right? Because it is in vacuum. Okay, and if it is in medium, then the wave is going to be omega upon c into n. Okay, so these are very important formulas you need to note down. Okay, this is wave number in vacuum, and this is in any media. Okay, or in any medium. Very important formula. Okay, which we know also. So this so now we know that is value of n is root epsilon r. Okay, that is relative permittivity. Okay, so we can write k equal to uh, k is wave number. Okay, so wave number of the electromagnetic wave equal to this formula, right? Because we know k naught, value of k naught is omega upon c, so we can write in place of omega, we can replace omega upon c by k naught. K naught into root epsilon r we can write, because n equal to root epsilon r. Okay. Okay. Dielectric medium, dielectric constant. Okay. So this is equal to root epsilon r, and epsilon r value is 4. Okay. So it means K is going to be K naught into root 4, K naught into root 4, K naught into root 4 value is 2, so it is 2 K naught. Okay, so value of wave number. Okay, so the wave number of electromagnetic plane wave is this option, right? Option number B. This is the answer. Option B. Option B. Okay, so very simple question. This the value of n is this formula is very important. K equal to omega upon c into n, and omega upon c is wave number in vacuum. Okay, we have put the value, and n, the value of n equal to root epsilon r, that is relativity permittivity, that is 4. Okay, and so that is going to be, this is the answer. Very simple question, one line solution question. Okay. Well, now next question. Question number 2. This was the question actually which was left in last class. Because of technical error, my class was ended automatically. Okay. Next question. This is the question of matrix. Okay, very good question, which I have already explained in mathematical physics, right? So this is the question which is asked in 2019 CSIR NEET physical science. Question is, the element of a 3 cross 3 matrix, 3 cross 3 matrix, 3 cross 3 matrix A are the products, if its rows and column indices, if its row and column indices, Aij equal to Ij. Okay, where Ij equal to 1, 2, 3. Okay, the eigenvalues of A are, the eigenvalues of A are, okay. Options are 7, 7, 0. Option B are 7, 4, 3. Option C are 14, 0, 0. Okay, and option B are 14 by 3, comma 14 by 3, comma 14 by 3. Okay, so these are the options. Okay, so so question is very simple. The element of 3 cross 3 matrix A are the products, okay, element of 3 cross 3 matrix A are the products if its rows and column indices Aij equal to Ji, which is given, okay, where Ij equal to 1, 2, 3, the eigenvalues of A you need to find. So we have given Aij equal to Ij, and this means any element of the matrix is equal to product of its indices, right? So this is going to be like matrix is going to be A11, A12, A13, okay, then A21, A22, A23, and then A31, A32, and A33, okay. So this is the matrix, okay. This is the matrix, sorry, okay. So according to question, these are like A11 is like Aij equal to Ji, right, I into J, means product of indices, right. A11 is going to be 1 into 1, that is 1 into 1, indices I equal to 1, J equal to 1, 1 into 1, 1. A12 is the indices 1 into 2, 2. A13 is 3. Similarly, 2 into A21 is 2 into 3 from this, right. So it is going to be 2, and A22 is 4, A23 is 6, 2 3 is 6. Similarly, 3 1 is 3, 3 2 is 6, 3 3 is 9. So this is the matrix, okay. This is the matrix which is given, okay, according to question. Now we have to find out the eigenvalues, right. So matrix is 1, is 1, and this is going to be 1 2, 2 we can write, 2 into 1 we can write, and then 3 into 1 2, and this we can write this one, right, 2 4 into 1, 2 into 2, sorry, 2 into 2, 3 into 2, and this we can write 3 into 2 and 3 into 3. We can write this matrix like this, okay. 1 2 is we can write 1 this we can write 2 into 1. So yeah, we can write this 2 to the 4 6 9 3, right. 2 to the 4 6 9 2 to, 3 to the 6. This is same thing, right. So there is a property which I have already explained in my mathematical physics lecture, right. So if if any so there is a definition, right, in if any columns or if any columns or rows can be written as a scalar multiple, right, can be written as scalar multiple of remaining rows and column, okay. In that case their eigenvalues are going to be trace of A comma 0 comma 0 for 3 matrix, okay. So if we can write any if we can write columns and rows as a scalar multiple, right, then in that case the eigenvalues are trace trace A comma 0 0, or if there is another definition we can say if Aij if Aij if Aij equal to Ji, right. This property I have directly explained as well in my mathematical physics lecture in matrix part, okay, or matrix lesson. So I have already explained if Aij equal to Ij, Aij equal to Ij, right, means any element is equal to product of its indices. In that case eigenvalues, the simple language, eigenvalues, we can write eigenvalues of that matrix is going to be trace A 0 0. if it is 3 cross 3 matrix, right? So this is already given, right? Simple. So eigenvalues are going to be uh, trace A means sum of diagonal element, right? Sum of diagonal element. Okay. So this is going to be 1 plus 4 plus 9 comma 0 comma 0, and this is going to be 14 comma 0 comma 0, right? So this is the answer. So which option is matching? Option number C is the correct option. Option C is the correct option. Very simple, right? So this is it is given in the question, right? If Aij equal to Ji, in that case eigenvalues of that matrix is going to be trace A 0 comma 0. Okay. If it is n cross if it is n cross n matrix, then it is going to be trace A into 0 0 0 and 0 n minus 1 times 0 0 0. Okay. Well, so very good question. Okay. Next question we are going to solve. Okay. Next question. Next question is question number 3rd. This is also a good question. In the following circuit, in the in the in the following circuit, in the following circuit, each device D, each device D may be an insulator, may be an insulator may be an insulator with probability with probability with probability P, or a conductor with probability with probability 1 minus P, 1 minus P. Okay. Okay, and I'll make a figure for it. This is like so I'm drawing the figure first. Okay. Okay, so this is D, this is D, this is D. Okay, D, this is D. Okay, and this, it is circuit. Okay, it is circuit. This is voltage. Okay, and the probability that the proba probability the probability that non-zero current flows through the circuit is, okay, non-zero current flows non-zero current flows through through the circuit is, okay. Options are 2 minus P minus P cube. Option B is 1 minus P whole to the power 4. Option C is 1 minus P whole square into P, and option D is 1 minus P into 1 minus P cube. Okay, very good question. Okay, now I'll solve it. Okay, question is, in the following circuit, each device D, so there's a device is given, okay, may be an insulator with probability P or a conductor with probability 1 minus P. So this may be insulator or conductor. Okay, what we have to find out, the probability that non-zero current flows through the circuit. So we need to find the non-zero current flows through the circuit. It means the current flow the circuit, the probability that the current which is non-zero, okay, will flow through the circuit. That's we need to find. Okay, so for finding this we know in electronics, right? This either this should be so this should be conducting. Okay, there should be conduction of current. Okay, and either all these three should be conducting, or either two should be conducting, or either one of them should be conducting. Then there would be non-zero current. Non-zero current will flow. Okay, if 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 all these are non means insulator will work, if they will work as an insulator, then they would no current is going to be flow. Okay, similarly if if D will work, this part of D will work as an insulator, then they will then no current will flow. Okay, so now for getting non-zero current through the this circuit, what should be the condition? Condition should be this device must be conducting, and out of these devices at least one device must be conducting, then there would be non-zero current in the circuit. Okay, I hope you understood it. Okay, so for that what we need to find, first we'll find for this, for these three devices at least one should be conducting. Okay, so for the, so how we'll find out at least one should be conducting, that I will explain. First we'll find probability of device 1 being insulator. Okay, okay, I'll write probability of device 1 being insulator is P, probability of device 2 being insulator is P, probability of this device being insulator will P, right? So probability of being all three device being an insulator. Okay, so probability of all three device, I'm writing this is three device. Okay, all three device being an insulator is going to be P into P, that we know, right, from probability. So this is P cube, right? Now probability that at least one Okay, this I can write as a. Okay, probability that at least one out of these three will be conducting, this we know, because probability of being all three as an insulator is p cube, right? So probability of being at least one device to be conducting will be 1 minus p cube. Okay, this is p. Now we'll find probability for this one. Okay, so probability, this we can say like b. Okay, so probability of being this device conducting is going to be 1 minus p, because right, for conducting it's 1 minus p. Probability for any device conducting is 1 minus p. For being insulating is p, right? So this is going to be 1 minus p. So probability of at least one device out of these three being a conducting is going to be this 1 minus p cube. This we know from probability, right? Similarly, the probability of this device being conducting is 1 minus p. So this I have divided denoted by pb. Okay, it means probability that I can write like this: probability that this circuit be conducting, and it's a probability that there the probability we need to find now probability that non-zero current flows through this circuit is going to be PAB. It's going to be 1 minus P into 1 minus P cube. Okay, so this is going to be answer. So which option is matching? Let me just check. Option D is matching, 1 minus P and 1 minus P cube. This option this is match. Option D, 1 minus P, 1 minus P. Very simple. So just we need to know only this one, right? In probability part, at least one of being the insulator, one of being the conducting, right? For that, first we'll find probability of this device, these three devices being insulating. Okay, so this is going to be p3 p cube, right? Now we will find probability that at least one of the one device out of these three devices being being a conducting, right? That is going to be total probability is 1, so 1 minus p cube, right? And the probability of this being conducting is 1 minus p, which we know. Then the probability that non-zero current will flow through this device is going to be, that is multiplied, will multiply these two probability, right? This we know. So PAB is going to be 1 minus p into 1 minus p. Okay, well, next question now, question number 4. So we are solving question number 4 now. This is okay, this is question this is the question of differential equation. Okay, so I'll write the question first. The solution of the differential equation of the differential equation the solution of the differential equation x dy over dx 1 plus x y into e to the power minus x with boundary condition yx equal to 1 equal to 0 is okay. Options are a very good question. X minus 1 upon x e to the power minus x. Option B is x minus 1 upon x square e to the power minus x. Option C is 1 minus x upon x square e to the power minus x, and option D is x minus 1 whole square e to the power minus x. Okay. Question is the solution of differential equation. This with boundary condition is given, so we have to find out the solution of this differential equation. Okay, so differential equation is given. I'll write the differential equation, that is x dy over dx 1 plus x into y is going to be e to the power minus x. This is the differential equation which is given. Okay, so we can write like this. We have to make this is a linear differential equation of order 1, right? So this is going to be dy over dx plus 1 plus x upon x into y, and then e to the power minus x upon x, right? So this now this is in the form of linear differential equation of first order. Okay, now we know how to solve it, right? First we will find out if integral factor, right? Integral factor, and that is going to be, we know, e to the power integration p dx, right? So this is p and this is q. Okay, p dx, right? The coefficient of y is p, we know. Here we can write p is 1 plus x upon x and q is e to the power minus x upon x. Okay, because the standard differential equation for this is dy over dx plus py equal to q, and this equation in this form, right? So here p is this, q is this, right? So we'll solve it. So it is going to be e to the power integration, value of p is 1 plus x upon x dx, right? Or we can write e to the power integration 1 upon x plus x dx, right? And we'll solve it. So it is going to be e to the power 1 upon x is log x plus x, right? And this is going to be 1 actually. 1 x will get cancelled, right? 1. So this is going to be e to the power log x plus x, right? Or we can write it, this is going to be x into e to the power x, right? We know log and e is going to be 1. This is x and e to the power x. So this is the IF, integral factor, right? Now we'll find out CF, right? So for CF, we know CF is going to be y into, that is solution, okay, y into integral factor equal to integral factor into q dx, right? We know. So this is going to be y into integral factor is x e to the power x. I have already got it here. X e to the power x e to the power x equal to integration factor is x e to the power x into q. The q is here, e to the power minus x upon x. Okay, we'll write it, e to the power minus x upon x dx, right? Plus c. Okay, so x will get cancelled and this will get cancelled. So this is going to be xy e to the power x is going to be integration dx plus c, and this is going to be xy e to the power x is going to be x plus c. Now we'll use boundary condition. Boundary condition is given. Boundary condition is, what is the boundary condition? This is x y x equal to 1 equal to 0, right? So x equal to 1, y equal to 0. We'll put here. So this is 0 equal to, this is 1 plus c, that implies value of c is minus 1. We'll put this value in equation, right? So this is going to be here, this is equation number, or this one, right? In this equation, you can say this is equation number 2, right? We can write here. So this is going to be xy e to the power x equal to x minus 1. Sorry, yeah, x minus 1, value of c is minus 1, right? So from here we can find the value of y. This is going to be x minus 1 upon x e to the power minus x. E to the power minus x, and this is the answer. So which option is matching? Let me check. Option number A is matching, right? This one, option number A. Okay, well, this is the one. Now next question, question number 5. This is question number 4, right? Question number 5. Question number 5 is, this is also a very good question. I will explain it by trick as well. Okay, this question is the value of the definite integral, the value of the definite integral, the value of the definite integral, integration 0 to pi d theta upon 5 plus 4 cos theta is, options are 4 pi upon 3, and option B is 2 pi upon 3, option C is pi, and option D is pi by 3. Okay, so this is the question, very simple question. Okay, and first I'm going to solve it by trick. Okay, so how we are going to solve it by trick? So there's a trick of solving this type of question. Okay, so trick is, I'll write the trick first. So we know if the integration is in this form, 0 to 2 pi d theta upon a plus b cos theta. Okay, in that case the integration is going to be directly 2 pi upon root a square minus b square. Okay, where a should be greater than b. Okay, should be greater than 0. Okay, this is the condition and this is the trick. Okay, so trick is 0 to 2 pi d theta upon a plus b cos theta. If this is the case, then directly we can write this, its integration 2 pi upon root a square minus b square, right? And a should be greater than b and b should be greater than 0. Okay, so we'll solve it. Now this is in the form 0 to pi, right? So we can convert it into this form 0 to 2 pi. So for now this is there is a limit, right? So now we are going to double the limit. So then we'll divide by 1 by 2. So it is going to be 1 by 2, 0 to 2 pi d theta upon 5 plus 4 cos theta. Okay, because there is 0 to pi, right? We have double the limit. We have done 0 to 2 pi. If we do that, we divide by 1 by 2. We multiply by 1 by 2. Sorry. Okay, So then we'll use the trick. So this is going to be 1 upon 2 into 2 pi upon root a square minus b. A is 5, 5 square minus 4 square, b is 4, right? So this is going to be 1 upon 2 into 2 pi upon 5 square is 25 minus 16, right? This is 9. 9 means root 9 is 3. Okay, so this is going to be pi by 3. Pi by 3, right? So this is the answer by trick. Very simple. And which option is matching? Option D is matching. Option D. Right? Now I will solve it by the by proper procedure, by proper method. Okay. So this is also very simple, right? First, we have to make this function in this form. Okay, this will form like 0 to 2 pi form. Okay, integration should be 0 to 2 pi cos sorry, this is going to be d theta upon 5 plus 4 cos theta, and this is 1 by 2. So I have to make this integration in this form, because actually question is 0 to pi, right? So I have to make it 0 to 2 pi. So I'll multiply by 1 by 2, right? So this is, so now what we are going to do for solving this, for solving this type of question with proper method, what we will do, will say let z equal to e to the power I theta. It means dz upon d theta is going to be uh, I into e to the power I theta, right? Or d theta is going to be dz upon I e to the power I theta, right? Iota into e to the power, and e to the power I theta is z, so it is going to be dz upon iz. Okay, so this is the dz, right? Now we'll put value here. So it is going to be 1 upon 2, 0 to 2 pi. This is going to be dz upon iz. In place of theta, d theta, will write this value upon 5 plus 4 cos theta. We can write cos theta value, we know, right? E to the power I theta plus e to the plus e to the power minus I theta by 2, right? We know the value of cos theta. So and e to the power I theta is z, right? So we can directly write 4 into z into 1 plus z. Okay, simple. Now you need to solve it. Very simple, right? So this is going to be, we'll write it, integration 0 to 2 pi dz upon iz. This is going to be 4. This is 1 upon 2 as well, guys, because e to the power I theta into 1 upon 2. So this will go here. Okay, how? Because e to the power I theta plus e to the power minus I theta upon 2, that is value of cos theta, right? Or we can write z plus 1 upon z upon 2, right? Because z equal to e to the power I theta, it means 1 upon z is going to be e to the power minus I theta, right? This is very simple, but I'm just telling you. Okay, so we'll write it and now we'll solve it. So the solution part is normal, right? I'll write it now quickly. This is going to be 1 upon 4 if you solve this, right? So this is 1 upon 4 z square plus 5 upon 2 z plus 1. Make sure that the coefficient of z square must be 1, okay? Else you will get wrong answer. Right, now we'll solve this for poles, right? For poles, and also here what we need to do is we need to find that, we'll find the unit circle. Okay, so this integration is going to be in the unit circle. Okay, unit circle. Okay, this we need to find. So this is going to be because we have converted, so this is going to be unit circle, 0 to 2 pi unit circle. So what we do to solve this from proper method, first we'll find first what we will do, we will put we'll say that z equal to, we'll put z equal to e to the power I theta, and then we'll find value of d theta. We'll put the value of d theta, and also we'll take it as a unit circle. Okay, unit circle. So this integration is going to be converted into unit circle. Okay, so now this one, right? So now we'll solve it. So this is going to be for poles z square plus 1 by 2 sorry 5 by 2, my apology, 5 by 2 okay, 5 by 2 z plus 1 equal to 0. So we'll use the formula, right? We can will simplify this. So by this formula, right, b equal to z equal to minus b Tharacharya formula, right? That is minus b plus minus root b square minus 4ac upon 2a, right? By this formula. So this is going to be z equal to minus 5 by 2 plus minus root minus 5 by 2, sorry, 5 by 2 whole square minus 4 into a. A is 1 and 1 upon 2 into 1. So if you solve it, so this value is going to give minus 2 and minus 1 by 2. So we can see that in unit circle, this is unit circle, right? So we'll convert this integration into unit circle, right? This is unit circle. So here we can see 2 doesn't lie within this unit circle, but minus 1 by 2 lies in this circle, right? Unit circle. So it means we'll find the residue at z equal to minus 1 by 2. So this is going to be limit fz, right? So this is going to be z plus 1 by 2 upon z plus 1 by 2 into z plus 2, right? At z tends to minus 1 by 2. And this is going to get cancelled. We'll put z equal to minus 1 by 2, right? And this value is going to be 2 by 3. Okay, so now we know the I integration. I is going to be 2 pi iota into residue, right? Residue, sum of residues, right? So this is going to be 2 pi I into, here what we have done is we have taken 1 by 4 here. 1 by 4 I will be here. This is going to be 1 by 4 I into 2 by 3. I get cancelled. 4 will get cancelled with this. This value is going to be 5 by 3. This is the answer. Okay. Very simple. Okay. So by this method we can solve it. So very simple. This is proper. I would request to you, or I would suggest you, in examination time, use this trick because you will solve quickly, because we have a less time in examination, right? So if we know the trick, so we can solve it by trick. But you should also know the proper method. So proper method is this. Okay, simple. What you need to do is you need to take z equal to e to the power I theta, and now this integration is going to be in unit circle. We have to take it. Okay, this limit is going to convert it into unit circle, and then we'll find value of theta, and z will put here and this integration will get converted into unit circle, closed integration in unit circle, and then we'll simplify it and we'll get the solution. Okay, well, next question, question number 6. Question number 6 we are going to solve. This is also a good question. Thermodynamics question, statistical physics question. Okay. Question is, in a system comprising of approximately 10 to the power 23 distinguishable particles, okay, each particle may occupy any of 20 distinct states, the maximum value of the entropy, per particle is nearest to options are, option A is 20 kb, option B is 3k. We can write kb is Boltzmann constant, right? I'm writing as 3 or ik. Okay, 20k, 3k, and option C is k means kb. Okay, Boltzmann constant, and then 10 ln 2k, and option D is, okay, option D is 20 ln 2k. Okay, so this is a question, one line solution, very good question. In a system comprising of approximately 10 to the power 23 distinguishable particles. So there are 10 to the power 23 distinguishable particles in system. Okay, each particle may occupy any of 20 distinct states. Okay, there are 20 distinct states, so each particle can occupy any one of them. The maximum value of the entropy per particle is nearest to. Okay, the maximum value of entropy per particle you need to find. So we know formula S equal to K ln omega. Omega is the microstate, right? So we'll find out microstate. Microstate is, because these are distinguishable particle, right? So this is going to be the distinct state is 20, right? 20 to the power n. N is the number of particles, okay, which are 10 to the power 23 approximately. So right, this is the omega for distinguishable particle. Omega, that is number of the microstate, is going to be the distinct states to the power number of particle, right? Distinct states are 20, right? 20 to the power n, right? So it means S is going to be, the entropy is going to be A ln 20 to the power n, right? So this is going to be, S is going to be nk ln 20, because by the property of log, right? And here we need to find out uh, here we need to find out this one, right? The maximum value of entropy per particle, it is saying, per particle, right? So per particle means, very good question, per particle means maximum entropy per particle means S upon N, it's asking, right? N is the total number of particles. So this is going to be K ln 20, and value of ln 20 is almost 3. Okay, ln 20 is almost 3, so it is going to be 3K, right? This is the answer. Which option is matching? Let's see. Which option is matching? Option number B is matching, right? Option B is the correct option. Okay, next question. Before that, I'll check the sound. Am I audible or not? Because I get this issue, right? Let me just check. In a system, yes, it's working. Right. This is the question number 6. Next question. Next question is, consider question number 7. Consider a classical gas, a classical gas in thermal equilibrium, in thermal equilibrium, at at temperatures temperatures T1 and T2, where T1 is less equal to T2, it means T2 is greater than T1. Okay, which of the following graph which of the following graph which of the following graph correctly correctly represents the qualitative behavior qualitative behavior of the probability density, the probability density which is function of probability density function of the x component of the velocity okay. And graph is given, so we have been given graph and we have to select correct option. Okay, graph, I will draw the graph. So this is going to be like this. Option A, this box. Option B, option C, option D, okay. I'll make a graph. So this graph is like this. These are straight lines, guys. My drawing is not good. Okay, next I'll solve like this. Okay, so this is going to be this one, and another one is this one. This one is T1 and this is T2. Okay, this is graph. Second is this one. I think different pen should be used. Okay, this is better. And then this one. Okay, this is T1 and this is T2. Okay, option C is this is T1 and this is T2. Okay, and this is some like this. Next is the okay. This is T1 and this is T2. Okay, so these are the graph. Okay, so here I'm going to solve it. See, question is, I'll read it for you. Consider the classical gas in thermal equilibrium. Classical gas which is at thermal equilibrium at temperature T1 and T2. T2 is greater than T1. Okay, which of the following graph correctly uh, represents the qualitative behavior of the probability density function of x component of velocity? Okay, so here I'll show you this graph like this. Okay, so this is Vx, velocity component, and this is probability function. Okay, this is V, probability of function of Vx. Okay, similarly this is P Vx, and this is the probability density. Okay, and this is Vx. This similarly P Vx, and this is Vx. This is P Vx, and this is Vx. Okay, well, we'll solve it. So we know that probability function, okay, probability density function of x component of velocity. This we know. We know function of x component of velocity is this formula, right? We know that is m upon 2 pi kt, 2 pi kt, 2 pi kt to the power 1 by 2, right? And e to the power minus m vx square upon 2 kt, 2 kt, right? And where Vx is between minus infinity to plus infinity. Okay, so and also we know Vx, average value of Vx is 0 and average value of Vx square, right? This is kt upon m, and vrms, or we can write Vx rms, right? Vx rms, right? Vx rms, we know this value is root kt upon m. Okay, so from here we can see that the mean value, so mean value remains the same, but rms shifts towards right or left. Okay, so we can see, because if t changes it will shift, right? So mean value remains same, mean value remains same, and rms value shift shift shifts towards right or left, because if we change this, it is 0, right? But it will remain 0, where it remains same, but this, if t changes, then this is going to be changed, right? So shift towards right and left. Okay, and hence area under curve is same. Okay, hence area under curve is same, hence area under curve is same. Okay, so thus distribution is broad. Okay, thus distribution is broad, thus distribution is broad. Okay, so it means area under curve will remain same, and right, and rms value shifts towards right or left, hence area under curve is the same, right? So which option is matching here? Option C, right? Option C is the correct. Okay, this is the area is same, and it's t1 period, right? Only the t changes, then this shifts left or right. Okay, others are not going to be same, right? Well, next one. So C is the correct one, guys. Okay, option C. Only this is shifting. Okay, but area under curve is same. Well, next question. Question number 8. Question number 8 is the equation of state of an ideal gas. The equation of state of an ideal gas. The equation of state of an ideal gas is PV equal to RT at very low temperature. At very low temperature, the volume expansion coefficient, the volume expansion coefficient the volume expansion coefficient, that is 1 upon V del V upon del T, del V upon del T at constant pressure, at constant pressure options are diverges as 1 upon T square, diverges, 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 diverges as 1 upon T square, B diverges as 1 upon T. Option C is vanishes as T, vanishes as T, and option D is independent of pressure of temperature, is independent of the temperature, is independent of the temperature. Okay, okay, very good question. Question is, okay, this is the question. The equation of state of an ideal gas is P equal to PV equal to RT. Okay, at very low temperature, the volume expansion coefficient, that is 1 upon V into dV upon del V upon del T at constant pressure diverges as 1 upon T square, diverges as 1 upon T, vanishes as T, or is independent of the temperature. Okay, so we have been given very good question and very simple. We have been given PV equal to RT, the equation of state of the of an ideal gas. Okay, equation of the state. So we have been given PV equal to RT. You can say equation number 1. Okay, or we can write from here V equal to RT upon P. This we can say equation number 2. Okay, now alpha, that is the volume expansion coefficient. Alpha is, we know, 1 upon V equal to del V upon del T. This is given 1 upon V equal 1 upon V into del V upon del T. That is volume expansion coefficient. Okay, so this is going to be 1 upon V, and del V of V value is this, right? Del V upon del T into RT upon P, right? And so this is going to be 1 upon V, and this is going to be R upon P, right? Or we can write 1 upon PV, R upon PV, and from 1 PV equal to RT. So this is going to be R upon RT, or it is 1 upon T, right? So alpha value is 1 upon T. Okay, and so we can see 1 upon T. So this implies if T tends to 0, if T tends to 0, alpha is going to be infinity, right? Alpha is tending to infinity. Okay, so it means so this means this option is correct. Okay, so the volume expansion coefficient 1 upon V del V upon del T at constant pressure diverges as 1 upon T, right? Because this is diverges as 1 upon T, diverges as 1 upon T, right? Because value of alpha equal to 1 upon T, and if you put T equal to 0, alpha is going to be infinite, right? So diverges as 1 upon T. So option C is the correct option. Sorry, option B is the correct one. Okay, well, so guys, okay guys, so I'm going to stop here. And also guys, I would request the people who haven't subscribed my channel, please subscribe my channel and watch my lectures, which are absolutely free of charges and are going to help you to crack the exams related to physical science. Okay, okay guys, so okay guys, so in this lecture I have solved eight questions of CSIR net physics PYQs of June 2019. Okay, very important questions. Okay, so I would request you uh, keep on revising and practicing, which is going to help you to crack the exam. Okay, for cracking examination, revision and practice is mandatory. If you are not going to do that, then it's very tough to get to clear the exam. So I would request you keep revising, keep practicing. Okay, and definitely you are going to get whatever you wanted to get, right? Your goal of cracking the national examinations related to physical science. Okay guys, bye now.